Unit 10, Part 4. Sorry about that. Mummy is washing the kids' hair, and that causes crying. All right, so I was saying, why are quantifiers cool? Why is this predicate logic cool? You can make sentences, not on, with this new resource, this new element. We're building our this logic with the element of the propositional function, crucial foundational element. We can make sentences not only by substitution instances to singular sentences from X is Australian to Dan is Australian. Another way we can make sentences is by annexing or prefixing, right, putting at the start of, prefixing the propositional function with a quantifier, allowing us to express normal English sentences like Australians exist, or you might say UFOs exist, right? UFOs exist would be UX, what's that? That's the propositional function. X is a UFO. Okay, put an existential quantifier in front of that. So just that. There exists an X such that UX. There exists an X such that UX. UFOs exist. Okay? Quantifier statements are a class of English sentence. Same for any other language. We're doing English. Right, so English sentences there's a class of English sentences which do not predicate of individuals or classes, right? They're a class of sentences, complete things which are true or false, right? Which do not predicate of an individual, Dan is Australian, for example, that do not predicate of a class, like Australians are surfers, right? But rather, do this. This is what a quantifier statement is. So, difference between quantifier statements and categorical statements. But this is what a quantifier statement is. A quantifier statement is a statement which tells you of how many things a predicate is true. Or, in our formal language, a quantifier statement is a statement which tells you of how many things a propositional function is true. Right? How many? Why are they called quantifiers? Because they tell you how many, right? We're only concerned with two basic quantifiers, universal quantifiers, which tells you the propositional function is true of all of them, or all things, or the existential quantifier, which tells you that the propositional function is true of at least one thing, right? There exists an X such that there is at least one. That's the bare logical meaning, the basic logical meaning of the existential quantifier. There's at least one of these things that exists. There are Australians, means there is at least one Australian, right? And of course, the other sentence I can make with a quantifier with this basic propositional function is this sentence. Sorry, for all, that's just an X, for all X, AX. What does this say? Oh, wouldn't it be wonderful if it was true? For all X, X is Australian. Everything is Australian, right? So those are sentences that we can make, right? They do not have subjects, right? They've got the propositional function. They tell you of how many things the propositional function is true, right? So that's how we symbolize. That's how we symbolize them. So these are what you're introduced to in Unit 11. They're called simple quantifier sentences. So we introduce into the quantifiers and how they combine with propositional functions. Right, that's Unit 11. Unit 12 introduces you to categorical propositions, which are slightly more complicated quantifier statements. Right. So definition of a categorical proposition is a statement which has a subject and a predicate and expresses a inclusion or exclusion relation between the subject and predicate, something like that. Get that right when we get to Unit 12. Okay, so back to this argument. Dan is Australian, that's our symbolization of that. When we learn categorical sentences, Unit 12, we'll learn, okay, so most quantifier statements in English are not as simple as everything is this simple propositional function, right? We don't often say everything is Australian, but most of your use of quantifiers, the English words all or some or even most is kind of a quantifier, right? Usually these are speaking of an entire class, right? As opposed to all of the things in the universe, right? So the point is, in what we learn in Unit 11 with the simple quantifier statements is a beginning, but it doesn't give you great expressive power. It doesn't give you power, the power you need to capture or formally express most of the English sentences in which you use quantifiers. What you need is categorical propositions, because usually when you use the word all, for example, you're speaking not of all things in the universe, but of all of a particular category or group, right? So sometimes examples of what you can express with simple quantifier statements is something like everything has a gravitational pull, physics statements like that. Gx, right? Let Gx be x exerts a gravitational pull on the Earth. Right, it's an example they use in the chapter. Gx equals x exerts a gravitational pull on the Earth. Okay, here's a universal statement for all x, right? For everything that exists in the universe, that's what that means. X exerts a gravitational pull on the Earth. It's true, but outside of physics, you don't have so much use for these simple, this is called a simple universal statement. I call these simple quantifier statements, right? It's a simple existential statement, simple universal statement. What makes them simple? It's the quantifier attached to merely a simple propositional function. But most of the use of the quantifiers is a little more restricted than that, right? It is something like all Australians are surfers, or right, Australians are surfers. Americans are happy, right? Russians are cool. Whatever, right? You're predicating of a class. So when I say Russians are cool, it's implicitly, all Russians are cool. The quantifier is kind of implicit, but I'm speaking of, you have to think it like this. The quantifier for all x is saying for everything in the universe. We'll get more into how this works in Unit 12, but the way the correct logical form of a statement like, well, let's just work with all Australians are surfers, is this. For all x, which means for every x in the universe, for every x in the universe, right, and then the brackets means basically this propositional function is true of everything, right? This is a complex propositional function, which we're introduced to here in Unit 10, right? And this complex propositional function says what? Start with the major operator. If x is Australian, then x is a surfer, right? So what does it say? It says it's true of everything in the universe that if that thing is Australian, then that thing is a surfer, okay? And Unit 12 will introduce us to how this is true of all things. Right? This piece of chalk is not Australian, right, and not a surfer, but this claim is also claiming of this, because this is for all x, means for everything in the universe. But because this piece of chalk is not Australian, the antecedent is false. So for all x, if x is Australian, then x is surfer. It's true of this, because since this piece of chalk is not Australian, the antecedent is false, which makes the conditional true. Okay, that's just sort of a taste of how it goes. Read through chapter 12. We'll go through it in more detail of the lecture for chapter 12, but this is why, that's a first taste of why the correct logical form of a quantifier statement, like our first premise in the argument we started with, all Australians are surfers, is the universal quantifier combined with the hook in the complex propositional function here. This is still a propositional function, right? The thing without the x, the thing in the brackets. Why? Because it has variables. It's incomplete in itself, right? If you're asked an exam, which you very well, or a quiz, which you very well may be, whether the following bunch of words is a singular sentence or a propositional function or a quantifier statement. How do you know if it's a propositional function? If it has a variable, it's a propositional function, right? If the thing says x is blue, it's got the variable x, that's how you know it's a propositional function, right? Propositional functions are variables, because that's why they are neither true nor false, but need to be completed by substituting the variable for an individual variable, for an individual constant, sorry, or they need to be completed by annexing a quantifier to make a quantifier statement. Either way makes a sentence out of what is not a sentence, namely the propositional function. Anyway, all right, so we've got, that's our symbolization of the two premises of this argument. So back to the beginning, it was why we're doing predicate logic, because this is obviously a valid argument, couldn't capture or express formally the validity of the argument with the resources of sentential logic, so we're now doing new logic. That logic yields the analysis of those two sentences as so, right? A D, singular sentence, substitution instance of the propositional function, a X is Australian, to yield the singular sentence Dan is Australian, right? The universal categorical statement, all Australians are surfers, gets this analysis, which you will become more convinced of as you study chapter 12. For all X, if X is Australian, then X is a surfer. That's how you say all Australians are surfers, right? That's how you symbolize it. That is the correct logical form of it, according to this analysis, right? So that's our two premises, right? Now, what was the conclusion we wanted to prove? Dan is a surfer, okay? So that gets symbolized, and you should understand this now, as SD. What is this? A substitution instance of the propositional function Sx, where Sx equals X is a surfer, right? I'm saying the equals, read chapter 10, she'll give you, we're often given a definition of a propositional function with the triple bar sign and to say equals.